Everyone. So today we're going to continue with the overall topic of vectors, and specifically we're going to be talking about scaling vectors and adding and subtracting vectors. So to start off, we got to discuss a vocab term. So you know what vectors are? They're like arrows, and we label them with a letter and an arrow over it, right? Like this vector here might be called vector v. But in the context of vectors, there's a term that we use for normal numbers. So vectors are arrows. Compare that with what's called scalars. And scalars are a special term we just use for any normal number. So for example, the number 3, or a variable without an arrow over it in this context would represent any number, some number that we don't know, right? So 3, x, those would be scalars as opposed to vectors, which are arrows. One more thing though, depending on the context, for example, in some textbooks, people instead label vectors with a normal letter with no arrow over it, but bolded. So this bold V would refer to a vector, right, an arrow. And then with scalars, they would use a non-bolded normal number like x. Bolded V for an arrow, x for a normal number. Now let's talk about scaling vectors. And all that means is we're stretching or shrinking vectors, kind of like how you might have learned about dilations in your past work. So here's a vector v, and let's say its magnitude, as in its length, is 8. Well, you might be asked to work with something like 3v. And all that means is take vector v and multiply it by the scalar 3, right? We call this scalar multiplication. And as you might imagine, what that does is you get a vector with 3 times the length, although note that this new vector will be in the same direction. So 3v would look like this, and we think of it as both vectors starting in the same place, at the origin, at the tail of the original vector. And so, of course, this new red vector will have magnitude 8 times 3 is 24. Let's just separate these vectors so it's easier to see. So again, we have the original vector with magnitude 8 and the longer vector 3v with magnitude 24. Just know that when we multiply by a number less than 1, so like 0.5v, for example, 1/2 of the original vector v, then as you may have learned in your previous work, you'll get a smaller or shorter vector like that. And of course, if the original has magnitude 8, 0.5 of that, this smaller vector will have magnitude 4. Now, what about negative scalars? So we have our original vector v here with magnitude 8. What would something like negative 2v look like? Well, you're still going to get a vector with twice the length, but you might remember multiplying by a negative, you can think of as like flipping something. So negative 2v, what you're going to get is a vector pointing in the opposite direction with twice the length, like this. So a vector pointing like 180 degrees away from the original, but with length 16 because it's minus 2v. So that's the conceptual idea behind scaling vectors. That's how we visualize it. Now let's talk about the math of scaling vectors, and it turns out it's super easy. Here's an example. It says let v equals 7 comma 4. Remember, those are the horizontal and vertical components. And it says find 5 times v and sketch the situation. And again, it's super simple. So 5v, right? 5v. And how it goes, you can also write this as 5 and then times the vector in component form. So 5 times 7 comma 4. And all you do is you multiply the scalar on the outside by each component. So 5 times the horizontal component 7 is just 35. And then 5 times the vertical component 4 is just 20. And boom, this right here is the component form of 5v. And then sketching the vector, so the original v was 7, 4. So starting here, we go right 7, up 4. So maybe slanted like so. And then the new vector, 5v, And we know that it's 5 times long, and it makes sense because the new vector now goes right 35, up 20, right? So draw the new ones slightly away, but starting at the same point, again, we're just going 5 times more to the right, 5 times more above, and boom. This one's the original, new one is 5v. I would just caution you in working with negative numbers. So we have scale the vector 5 comma negative 3 by the scalar negative 2. We have negative 2 times 5 negative 3. And you know, you've dealt with this before. Just be careful with the negative signs. Negative 2 times positive 5 is negative 10. And then negative 2 times negative 3 would be positive 6. There's our final vector. And maybe this kind of illustrates why the flipping of the vector happens, because the original goes, let's see, right and down. So like this, that's the original, right? Right 5, down 3. But now the new one, it's negative 10, positive 6, as in it goes left, then up, and is twice as long. So the new one goes this way, and that's how that goes. And so like we said before, negative numbers do scale the original, but it also flips the new vector to face the complete opposite way, right? 180 degrees away. Now let's talk about adding vectors and also subtracting vectors. And it turns out mathematically adding vectors is pretty easy, but before that, let's talk about the conceptual aspect, okay? So here we have an airplane, and if you remember, we talked about an airplane example in a previous lesson. And again, think about the velocity as in the speed and the direction of movement of the airplane. Or similarly, we could talk about the forces acting on the airplane, right, that push or pull the airplane to move it. So like in the previous example, this airplane, its jets or propellers are trying to push it forward. So its velocity, its movement would be like this. And actually the forces that this working on this plane would be the same direction as well. But the problem is there's some strong winds coming from this direction, let's say, air current and such. And those strong winds are going to affect the airplane in some way, are going to exert the force on the airplane, right? And in physics, when you're talking about forces, we talk about the forces acting on the plane. So what you might, if you've taken physics before, what you might draw is so the force of the propellers acting on the plane. There's a plane center. And then the wind also acting on the plane like this. And as far as each vector individually, you could say this is like a proper way to draw them, with each vector has its tail. It starts at the plane because it's acting on the plane. But as far as adding the two vectors together, there's another way that we might want to think about it. And this other way we think about it is, let's start with the velocity from the propeller of the plane, right? And then we say, well, the velocity of the wind affects the plane as follows, or the velocity of the wind combines with the original velocity of the plane as follows. Starting here at the head of the first vector, we draw the second vector, right? The wind is going this way. And so what happens is this blue vector from the plane's propellers and the red vector from the wind combine for a total movement of the plane veering off like this. So this green vector is the result of the blue and red combining, as in we've just added the blue and red vectors to get the result. The result of this addition is called a sum, right? This green vector we would call the vector sum of the blue and the red. We also call that the resultant. And so the point is, we take one of the vectors with the tail at the origin, we start with that vector, but then for the second vector, we start at the head of the first vector, put the tail of the new one there, and then from there follow the second vector to its head. and the result starts at the original origin or the original tail and then points to the head of the last vector that we added. So again, the total effect is that the plane veers off a little bit. Now, that was the conceptual or visual aspect of it, but like I said, mathematically, this adding is super easy, so long as you have each vector in component form. So here we have an example. Consider the vectors a equals 3 comma 7 and b equals 5 comma negative 2. What is a plus b? As in, what do you get when you add them? What is the sum? Well, how this goes is like, okay, you got a plus b, in other words, bracket 3 comma 7 plus bracket 5 comma negative 2, right? And all you do is add the corresponding components. So we got the horizontal components of the first vector is 3, second vector is 5. So the total result is a horizontal component of 3 plus 5. And then the vertical component, first vector is 7 plus second vector, of course, as always, be careful of negative numbers, so plus negative 2. So of course, the total result is 3 plus 5 is 8. 7 plus negative 2 is 5. And just to see this visually, let's draw this. So let's start with a, 3 comma 7. That means, so start with the first vector, we start at the origin, right? And we go right 3 up 7. So let's see, right 3 up 7. That's this vector or arrow here. And so this blue vector is a. But with the second vector, b, if we were just graphing b, we would start at the origin. But we're trying to combine them, right? So start at the head of a right here. That point is where we're going to start graphing b. And b is 5 comma negative 2, right? So from this head, there we start by going right 5 down 2. So right 5 down 2, this right here is how b is going to combine with a. And now the total result, the vector sum, the resultant vector, well, is what we got correct. We got 8 comma 5, right? Well, starting at the actual origin, so starting at the tail of the first vector and going to the head of the second vector here, right? Starting at the origin, let's see, right 8 up 5. That's exactly what we got. So going from here, the tail of the first vector to the head of the second, boom, that's the total result. That is a plus b, the sum. So our work was correct. Yeah. All right, so we're done with covering all the basics for today. And we're almost done. But of course, now it's time for more complicated examples. So here we have a problem. Let v equals 4 comma 5 and w equals 2 negative 3. Find the component form of the linear combination 3v plus 2w. And linear combination really just means we're multiplying by scalars and adding stuff. So we're just combining scaling and adding, which is what we learned today. And then also sketch the situation. And you know, it's a little more complicated, but I think it's still pretty straightforward. So let's see, we have 3v plus 2w, right? All that means is 3 times what is v? V is 4 comma 5. Plus 2 times what is w? 2 comma negative 3. And you know, just know that you just have to do the scalar multiplication first. So multiply the 3 first, 3 times 4 and 5, so you get the scaled version of v is 12, 15. And then you also have to do the scalar multiplication for the other ones. So you have to do all scalar multiplication first. 2 times 2 is 4, 2 times negative 3 is negative 6. And now, after you're done with all the scalar multiplication, you can add them. And how we do that, remember, you add the components, the corresponding components. So 12 plus 4 is 16. 15 plus negative 6 is 9. And so mathematically, that's our result. We're done. But again, let's visualize the situation, okay? And our graph doesn't have a set origin, so let's just pick one, maybe down here. And so 3v plus 2w. So basically, you can think of it as we're starting with v, and v goes 4 to the right, up 5. So here's the original v, but then we're scaling it by 3, right? Starting where we started, scaling it by 3, we go over 12, up 15. Basically, we have 3 of these arrows. 1, 2, 3. Boom. And this red vector right here will now be 3v. Now, what about w? So we're adding 3v and 2w, right? So we're going to start at the head of 3v, and that's like our new origin, if you will. And then w, the original w is 2, negative 3. So we go right 2, down 3, and this would be our original w. But we aren't adding 1w, we're adding 2 w's. So instead of going over 2, down 3, we're going over 4, down 6, as in 2 of these, 1w, 2w. So this vector right here is 2w. And so we've got the two scaled vectors we're adding, 3v and 2w. So the final result, adding those two together, we start at the original origin, the tail of the first vector, and end here at the tail, at the head of the second vector. And so again, the final result is this long green vector here, right? That green vector is what we were looking for, 3v plus 2w. And was our math correct? 16, 9. Is that what we got? Over 16, up 9. Looks like it. So we're done. So one very last thing, what about subtracting vectors? So here we got some examples with the same vectors that we used, v and w, from the previous example. And it says find each of the following, v minus w, and then 3w minus 2v. So basically subtraction, if you think about it, it's just like it's just addition with one more step. What do I mean? V minus W, how you want to think about this is it's just V plus, well, V minus W, that's V plus negative W, as in negative 1 times W. So basically what you have is the original V, so 4, 5, and just add that with negative 1 times w, so 2, negative 3. So again, you're just adding the original v with a scalar multiple of w, right? It's another linear combination. And again, you have to do the scaling first, so v is just 4, 5, but then negative w is negative 1 times 2 and negative 1 times negative 3, so negative 2, comma, positive 3. And now we're just adding two vectors, and you know how to do this. What is that? 2, 8. And we're done. Now, what about 3w minus 2v? Again, same deal, but also with this problem, take note, for whatever reasons, mathematicians like to use like similar letters for different things, and you have to pay attention to which one's first, right? So if you did this new problem in the same way as we did the one above, you'll be wrong because in this new one, w is first and not v. Just take note of that. And again, what's going on is 3w minus 2v equals 3 times w, which is 2, negative 3, plus negative 2 times v, which is 4, 5. And now you would just do the scaling again, right? 3 times 2, 3 times negative 3 is 6, negative 9, plus negative 2 times 4 and 5, so negative 8, negative 10. And again, now we're just adding. 6 and negative 8 is negative 2, negative 9, negative 10 is negative 19. And so that's our final answer. So as usual, I hope all that made sense. Make sure to contact me with questions or comments if you have any.